Hi students, this is Mr. Yao. Today we are going to learn about statistics. More specifically, we are going to learn about box plot. But first, prior knowledge, let's review what we have learned previously. Since we are going to use the median in this lesson, let's review about mean, median, mode, and range. Here's a data set. In order to find the mean, median, mode, and range, specifically median, we need to put them in order from the smallest to the biggest. So let's do that first. 10, 14, 17. Then we have 28, 33, 34, 42, 48, 52, and 60. Okay, next, let's calculate the mean. There are 10 numbers in total, so we're going to add them all together, and that should give you 338 divided by 10, which means the mean is 33.8. Mode is the easiest, but in this case, there's no number that is appearing more than the others. They all just appeared one time. So in that case, mode is NA. Range, that's going to be the biggest minus the smallest, so 16 minus 10, which is 50. As for the median, we have 10 numbers, so we know we have to keep the middle 2. So let's cross out from both sides. That's 1 pair, 2 pairs, 3 pairs, 4 pairs. So we have the middle pair left. 33 plus 34 divided by 2 is going to give you 33.5, and that is the median. Now let's get to box plot. Box plot, or in other words, is also called box and whiskers plot because we're going to draw whiskers. It's a good way to show the spread of the data, which is also called 5-number summary. And here are the 5 numbers that we need. We need the minimum and the maximum. That's a guarantee. We need the median, which we have learned how to find. And we also need something called first quartile and third quartile. If you notice the word quartile, it has the Q-U-A-R. Another similar word could be, in a school year, we have 4 quarters. So quartile is also related to that. So first quartile basically means the first 25% of the data. Second quartile is the second 25, which means that's going to stop at 50%. Third quartile is going to be the 75% of the data. So that's how we're separating the data, basically into 4 quarters. And then we name them as first quartile, second quartile, and third quartile. The fourth quartile, of course, is already the maximum number. So here they are. First quartile, we use Q1 to present. That is going to the median of the lower half of the data or the max of the bottom quarter of the data. Third quartile is Q3 is the median of the upper half of the data or the max of the third quarter of the data. So let me quickly draw a little diagram. Let's say this is all the data. We have the minimum and we have the maximum. Of course, if we cut right in the middle, we have the first 50% of data and the second 50% of data. And in the middle of that 50%, let's say this is 25%, there's another 25%. This is going to be your Q1 because that's the the median of the lower half of the data. This is the lower half of the data and it's right in the middle. So that's your first quartile. It's also the maximum, the biggest for the first section, for the first quarter. And then if you look at the upper half, in the middle of the upper half, which means we're still dividing them into quarters. So you have a 25% and another 25% of the data. This will be your Q3. That's why it's saying it's the median of the upper half of the data. So it's right in the middle of the upper half of the data. It's also the max of the third quarter of the data. So first quarter, second quarter, and this is the third quarter of the data. And the number we need is the maximum of that. So that is the Q3. Hopefully this kind of give you a visual idea about how to separate the data. Interquartile range, or in short, IQR, that is the range of the middle 50% of the data. Middle 50%. Here they are. That's the middle 50% of the data. The middle 225, 2 quarters. So middle 50% of the data, and that is going to be the difference between Q1 and Q3. So no matter what, you need to find the median of the lower half, the median of the upper half, and when you subtract them, it's going to be called interquartile range, which kind of makes sense. Interquartile is kind of going between quarters, and range is always the biggest minus the smallest. So in that middle 50%, the biggest number is Q3, the smallest number is Q1. So to calculate is going to be Q3 minus Q1. So there they are. Now let's actually get to some examples. whenever you want to find the box plot or box and whisker or 5-number summary, you do need to arrange the data in ascending order. So smallest number first. 2, 4, 5, 2, 4, 5. Then we have a bunch of 8, 8, 8, 8. And we have a 10, a 12, and a 12. 10, 12, 12. 1, 2, 3, 4, 5, 6, 7. We have 9 numbers. Okay. Second step, we're going to determine the max and the min and draw the whiskers at max and min. The smallest number is 2. So let's label the number line 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The minimum is 2, maximum is 12. Here's a whisker. Whisker is just a little line that we draw instead of a dot. So here's a whisker at 2, that's the minimum. Here's a whisker at 12, that's the maximum. Step 3, we're going to determine the median. There are 9 numbers in total right now, so let's start counting. 1 pair, 2 pairs, 3 pairs, 4 pairs. Then we have the middle number left, which is at 8. So that is going to be my median, which is also called Q2. Some of you might be like, Mr. Yao, I thought typically we just cross the numbers out. Well, in this case, because we still need to find the median of the lower half and the upper half, kind of don't want to cross them out. I can cross them out in that step. I still kind of want to keep them, so I'm just counting pairs this way. Next is to determine Q1 and Q3. Now here's the thing. We have used this middle number as our median. That means the median is actually a number in the data set. We have used it already, so we can't use it anymore when we try to find the lower half and the upper half of the data. So now that means the lower half of the data, we have 4 data left, and the upper half, we also have 4 data. So for the lower half, if you start finding the median, you have 1 pair, then you do need to find the middle of these 2 numbers, which is going to be 4 plus 5 divided by 2, and that is 4.5. So my Q1 is going to be 4.5. That's my Q1. Which is at, I need to draw it slightly to the right probably, so it's a bit more precise. There we go. That is 4.5. Okay. And then for the upper half, I'm going to do the same thing. So cross out a pair, and then we're left with the 2 middle. 10 plus 12 divided by 2 is 11. So my let me actually use a different color. So my Q3 is going to be at 11. Now I have all the whiskers, and as also you can see there are 5 of them. That's why it's called 5-number summary. Next, we need to draw a box. The box is to connect the middle 50% of the data so that we can easily see the interquartile range, middle 50. So the box is generated by just connecting Q1, Q2, and Q3. But since the other 2, the maximum and minimum, they're still part of the data set, we're still going to use a line to connect them with the minimum and the maximum. Lastly, if the question asks you to find IQR, in this case, let's find it. IQR is going to be the Q3, which is 11. So I'm going to actually write that down. And Q1 is 4.5. So it's going to be 11 minus 4.5, which is 6.5. That is example 1. That's how we generate a box plot or box and whisker plot or 5-number summary. Let's move on to do a few more examples. Okay, example 1, same thing. The numbers, well, the good thing is for this one, the data is already in order. So let's get right to it. Minimum is at 3. So let's draw a whisker at 3. Maximum is at 48. So let's draw a whisker at 48. Next. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 numbers. So you kind of know from odd amount of numbers, you have to have a number left in the middle. So 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs, 6 pairs. You're left with a 17, which is right in the middle. And that is going to be my Q2, which equals the 17. And since that 17 is in the data set, I can't use it anymore. So I'm going to cross it out so that I'm not confusing myself when I try to identify the lower half and the upper half of the data. So this is the lower half of the data. There are 6 of them. So let's start crossing things out. 1 pair, 2 pairs. We're left with 2 of them. 9 plus 11 divided by 2 is a 10. That means the Q1 has to be a 10. for the upper half of the data, right here, 6 numbers again. Cross out a pair, cross out another pair. We're left with 19 plus 22 divided by 2. That is going to be 41 divided by 2, which is 20.5. So it's slightly over. So 20.5 Q3 equals 20.5. And then we are going to connect the middle 3, so Q1, Q2, Q3 to make the box. That's the middle 50% of the data. So I'm going to connect that with the first, the minimum, and the maximum. There we go. IQR, that is Q3 minus Q1, which in this case is 20.5 minus 10, which is 10.5. And that is example 1. Moving on. Example 2. It's the same idea, and I'm going to ask you to pause here and try it out. Then you can come back to check your answers. Let's have a look. First step, of course, you got to put the numbers in order. 19, 23, 25, 6, 28, 19, 23, 25, 26, 28, 33, 33, and 35. 33, 33, and 35. There you go. Okay, we have 1, 2, 3, 4, 5, 6. We have 8 numbers. Okay, so let's start labeling them on the number line. You can choose to label them by 5s. So let's start with 15. 16, 17, 18, 19, that's a 20. 1, 2, 3, 4, 25, 6, 7, 8, 9, 30. 1, 2, 3, 4, 35, 6, 7, 8, 9, 40. There we go. Okay, so first, the minimum is 19, and the maximum is 35. We have these two. Now let's identify the median. There are 8 numbers, so you know you got to keep the middle 2. So 26 plus 28 divided by 2, that's 27. The median is 27, and here's the thing. You actually didn't include that in the data set. Even though we have used 26 and 28 to find a median, but the median actually is not appearing in the data set. So we're not exactly using that to, we don't need to get rid of anything. So we're just going to cut right in the middle. So for the lower half, we still have 4 data points. Now we can actually use that to find the median of the lower half, or Q1. Cross out a pair. 23 plus 25 divided by 2 is 24. So my Q1 is going to be 24. Oh, I forgot to label my Q2. Q2 is 27. Okay, now I'm going to do the same thing. Upper half, get rid of the 2 numbers. We're left with a pair. 33 plus 33 divided by 2, it's still a 33. So my Q3 is going to be 33. Again, if you have even amount of the numbers and you have the number that you haven't used, the median is not in the data set, then we do not need to get rid of any numbers. We just cut it right in the middle. Okay. Now lastly, we just connect Q1, Q2, and Q3. Then also connect with the minimum and the maximum. As for the IQR, IQR is going to be the Q3, which is 33, minus Q1, which is 24. That is going to give you a 9. Then we have 2 extra questions. Which quartile is the least spread out? And which quartile is the most spread out? When we have the word spread out, that just means how big of a little range is that quarter? Like how many numbers could be included in that quarter? So for example, if you look at the first quartile, that is from 19 to 25. So that basically has a range of 5. And the second quartile from 24 to 27, that has a range of 3. Third quartile from 27 to 33, that has a range of 6. And last quartile from 33 to 35, it has a range of 2. So in this case, you can clearly see the smallest quartile is the last quartile. So we are going to say that is the 4th quartile. Fourth quartile is the least spread out, and the 3rd quartile is the most spread out because that actually includes a range of 6. That's example 2. Example 3. So easily to identify, minimum is 9, maximum is 32. And you have all the 5 numbers, so that tells you this is Q1, that's Q2, that's Q3. So IQR is Q3 minus Q1, so it's 16 minus 12, which is 4. And then here's a little question you can pause here to think about. Should the minimum or the maximum actually be plotted as an outlier? The answer would, in this case, potentially be the maximum, because that is so far away from the rest of the data. Think about it. This is the first quartile, which only has a range of 3, then the second quartile range of 1, third quartile a range of 3, but the last quartile has a range of 16. That quarter is like so big compared to the other 3 quarters, which is why that 32 is kind of very far away. We will learn a specific way to identify the outlier in later lessons, but for now, at least by just thinking about the range of each quarter, you could be able to guess that 32 should be an outlier. And lastly, can you find the mean or the mode? Why or why not? Well, the answer in this case would have to be no, because you don't actually know the data set. You only know 5 numbers that are about the data set, but you don't know how many numbers are between 9 to 12. You don't know the actual data. So in this case, you can't actually do anything about the mean or the mode. That's why box plot is not for you to find the center, it's for you to find the spread. Okay, we have another special example. Let's practice. Minimum is easy to identify. It's outside the box, the first number, 72. Then with the box, we have Q1, Q2, and Q3. Q1 is 97, Q2 is 100, and Q3 is 103. Now, here's an issue. We don't see this little thing like popping out anymore. Well, then what's going on? We have the first quarter here, the second quarter here, the third quarter here. Where is the fourth quarter? If you think about it, if you don't even see it, if Q3 is 103 and that is in the middle of the upper half of data, probably means you have a bunch of 103, a bunch of 103. So even if you cross them out, you still will have 103 as the median. So that's why the maximum in this case could just be 103. And if that's the case, range would be max minus minimum. That would have to be 103 minus 72, which is 31. And IQR is Q3 minus Q1, which is 103 minus 97. That is 6. And you were asked to find the least spread out quartile. Q3 to Q4, they're just all a bunch of 103. So that means the range in that little quarter is actually a 0. So the fourth quartile would have to be the least spread out. And the first quartile, just by looking, is way bigger than the other one. So that is going to be the most spread out. Now, what does it mean when there's no whisker extending to the max? Technically, that could just mean Q3 is the same as the max, or in other words, there are a lot of 103 in the data set. That just is enough to be the max and also still keep your Q3 to be 103 as well. Okay, move on. The last one is just ask you to create a data set with at least 9 numbers given the box plot. So if it's 9 numbers, think about it. The middle number would just be 14, so that's your median. And then you just need a few numbers. You already know the minimum has to be 4. And the maximum in the data set has to be 23. So you kind of already have 3 numbers. Then you just need to put a few extra, another 3 in the middle of here of the lower half, another 3 in the upper half. So there's no one right answer, but I'll give you an example. 4 is the minimum. Let's say 14 is your median and 23 is your maximum. So you just need another few numbers right here and another few numbers right there. And you need the median to be 8. So if this is your middle number and you have 4 numbers, let's say, and you want the median to be 8, maybe they're just both 8 and let's say have a 9. Cut in the middle, that's going to give you a lower half Q1 as 8. As for the upper half, let's say 18, or then you want the 2 middle numbers to be 18, or then you just add an extra number, which is say 15. Now you have 9 numbers, and keeping the Q3 as 18 and Q1 as 8, the median is 14. And that is example 5, and that is everything for this box plot lesson. Thank you.